Namaste mere pyare bachon. Welcome back to the channel. I know your exams are just around the corner, so today we're going to dive into a chapter that's all about the pushes and pulls of our everyday life, force and the laws of motion. And trust me, we're going to make it super simple. Make sure you're subscribed and let's get right into it.
You know this feeling, don't you? You're just chilling in the school bus, maybe chatting with your friends, and suddenly the driver hits the brakes and whoosh, you get thrown forward. Or the bus suddenly starts and you fall backward. It's a daily mystery, right? Well, don't you worry. By the end of this session, you'll be the one explaining to everyone exactly why this happens. The answer is all in physics.
Now, to solve our bus mystery, we first need to meet the main character of our story. This character is literally the hero behind every single movement in the universe, from a cricket ball flying for a six to planets going around the sun. And that hero is force.
So, what is this force, really? It's so much simpler than you think. It's just a push or a pull. That's it. You know, you can't actually see a force itself, just like you can't see the wind, but you can definitely see what it does. When you push a book across the table, or when a batsman hits a cricket ball, that's the effect of a force in action. And let me tell you, force has some real superpowers. It can make something that's still start moving. It can stop something that's already moving. It can make things go faster or slower. It can change the direction, and it can even change an object's shape, like when you squeeze a rubber ball. It's unbelievably powerful.
Okay, so if force is so powerful, why isn't the wall of my room moving when I push it? I mean, I'm applying a force, right? This is because not all forces actually cause a change. And this brings us to a big fight, the epic battle between balanced and unbalanced forces.
And this picture explains it perfectly. Just think of a game of tug of war. You know, Rassi Khinch. When both teams are pulling with the exact same strength, bilkul equal force, the rope doesn't move an inch, does it? The forces are balanced. But the moment one team pulls just a little bit harder, the force becomes unbalanced and boom, the rope moves. Simple, right? Motion only happens when one side wins the fight.
It's the exact same thing when you try to push a heavy box. At first, you push a little, but nothing happens. Why? Because there's a sneaky force called friction from the floor that's pushing back, balancing your force. You have to push harder than the friction. So here's the golden rule. For anything to move, there must be an unbalanced force acting on it. Now that we're experts on unbalanced forces, we can finally talk about the genius who put this all together, the one and only Sir Isaac Newton. His first law of motion is the master key that's going to unlock our bus mystery once and for all.
Okay, I know what you're thinking. This sounds a bit heavy, right? An object remains in a state of rest or of uniform motion. Don't you worry one bit. It's actually super simple. Let's break this down into language that we actually use.
But why is this law true in the first place? What is this secret habit that all objects in the universe seem to have? Why do they resist change so much? Any guesses what we call this property?
The secret, bacho, is this one single word, inertia. This one idea is the property that explains absolutely everything we've talked about so far. So what is inertia? It's just a fancy, scientific word for laziness. Yes, you heard me right. All objects, whether it's a tiny cricket ball, a huge car, or even you, are naturally lazy. They resist any change. If they're resting, they want to keep resting. If they're moving, they want to keep moving. They just don't like to change their current situation.
And once you really get this idea of laziness, you'll start seeing it everywhere. Seriously, inertia isn't just in your textbook, it's all around you, every single day. I bet you've tried this famous Carrom trick. You make a tall stack of coins, and you flick the bottom one out with the striker. What happens? Only the bottom coin shoots out, and the rest of the stack just drops straight down. Why? Because of inertia of rest. The stack was just too lazy, it wanted to stay right where it was. And here we are back to our bus. Now you're the expert. When the bus suddenly starts, your feet, which are touching the bus floor, move forward. But the upper part of your body is lazy. It wants to stay at rest. That's why you feel like you're falling backward. And when the bus stops, your feet stop with it. But your upper body wants to keep moving forward because of its inertia. That's why you jerk forward. See? Mystery solved.
So you might be thinking, okay, sir, this is a pretty cool concept, but so what? Why is it actually important for us to know this in real life, apart from just for exams? Well, let me tell you, understanding inertia isn't just important, it can be a matter of life and death, because it is the single biggest reason why we must always wear a seatbelt when we're in a car.
Just think about it for a second. If a car crashes or stops very suddenly, your body's inertia will keep it flying forward at a very high speed. So what stops you from hitting the dashboard? This seatbelt. It provides that crucial, external, unbalanced force to stop your body and overcome its dangerous laziness. It's that simple. Seatbelts fight your inertia and save your life.
ठीक है? Now for the most important part, for all my future toppers, let's look at a pakka exam question on this exact topic and see how to write the perfect answer to get full marks. Pay close attention. Here is a very, very common 3-mark question. Explain why a person tends to fall backward when a bus suddenly starts. We already know the answer, of course, but the trick is, how do we write it perfectly? Okay, look at this slide carefully. To get full marks, you have to structure your answer just like this. Step 1, always state the main reason first. This happens due to inertia of rest. That's 1 mark, pakka. Then, you explain the parts. The feet move with the bus, but the upper body, because of its laziness or inertia, tries to stay put. Finally, you give the conclusion. This difference in motion is what causes the person to fall backward. Writing in clear points like this will really impress your teacher.
So, if we have to summarize our entire explainer in just one line, it's this. Newton's first law is simply the law of inertia, or, as we like to call it, the law of laziness. Things will just keep doing whatever they're doing, resting or moving, unless an outside, unbalanced force comes and messes with them. But wait a minute. We've only answered the why of motion today. We know why things move or stay still. But what about the how much? How do we actually measure a force? Why is it so much easier to push a small cricket ball than a huge, heavy box? What's the secret connection between force, mass, and acceleration?
Well, we will explore all of that with Newton's amazing second law in our very next explainer. So make sure you are subscribed and you hit that bell icon so you don't miss it. Share this with your friends so you can all study together and ace your exams. And please, let me know in the comments which example helped you understand inertia the most. Keep studying, Butcho, and I'll see you in the next one.